Hello students, welcome to Sreenath Academy. In this video, we are going to discuss the fifth chapter, which is Lines and Angles from CBSE Class 7th Max. So what is our present chapter, students? That is Lines and Angles. So in this video, we are going to learn about different angles and which angles are equal and what happened when a transversal is passing through two parallel lines. All this stuff you are going to learn now, students. Okay, so now we will see what are the topics or the concepts we are going to learn now. After that, we will discuss each topic in detail. So first, there is an introduction to the chapter, students, and what we have learnt in our previous classes. And after that, there is related angles. So in that, we are going to know about the complementary angles and supplementary angles and adjacent angles and a linear pair. And the next thing is about vertically opposite angles and about all these things, students. After that, the third topic is pair of lines. So in the case of pair of lines, there are intersecting lines and there are transversal also. So that is the case I have told you. And next thing is angles made by a transversal and transversal of parallel lines. So when there are parallel lines, if there is a transfer to it, what are the conditions? And next thing is checking for parallel lines. How to check for parallel lines? So this is the whole chapter we are going to discuss now, students. So these are the concepts now we are going to discuss. So finally, our chapter overview is completed, students. Hello, students. Now we will discuss the introduction and related angles in this video, students. Okay, so from the chapter Lines and Angles. So in the introduction, so what we are previously on is that we know about line segments, and we know about the lines, and we are also familiar with the rays. So for the line segments, there are two endpoints, and if you extend the line segment beyond the two endpoints, you will get a lines. So lines are like this. So no endpoints in the line. There will be no endpoints. And what about the ray? Ray will have one endpoint. On the another side, it will goes on extending. So there will be one endpoint. So these are the differences between line segments, lines and ray, students. So in this figure also, if you see, this is a line segment, this is another, this is another, this is another. So this is also have several line segments. So for this table also having 1, 2, 3, 4, all these are the line segments. House is also having line segments like that, students. Okay. So this is the line segment having two endpoints, and this is a line, and this is only one endpoint. So we are familiar with line segments, lines and ray, students. Here, what is the line segment? The line segment is PQ. We will represent the line segment by line like this. And what are the lines here? That AB is a line, students. So we will represent AB line by a like this, students. And how we will represent ray here? What is the ray? OP is the ray, students. We will represent the OP as like this. We will make one arrowhead on ray, and per line we will make two arrowheads. Just a single dash on the top of the PQ for line segment, students. So this is the way of representing line segments, lines and ray, students. Okay, so now, and we are familiar with, we have already learned with angles also. What is an angle? So angle formed by line segments. By using the line segments, we can form angle, and using the lines also, using the rays also, we can form angle, students. So basically, whenever the angle is formed, if you take two line segments, if the two line segments are intersected, suppose these are the two line segments, so these two line segments will form an angle here. There is an angle here. Okay, students. So this is the angle like that. Two rays, there are the two rays, they are extending, so they're starting from this point. So these two rays will also form a line segment, two rays, and two lines also can form line segments. Angle here, there is an angle, and these are two lines, so these two lines are also forming here angles. Here this is one angle, this is the second, if you name it, this is the first angle, this is the second angle, this is the third angle, this is the fourth angle. Two rays are intersected. Whenever two rays are intersected, we get angles. Whenever two line segments are intersected, in this case also we get angles. Whenever two rays are intersected, in this case also we can get angles, students. Okay, so in this triangle, here there is one angle, there is another angle, this is another angle. So this triangle is formed by line segments. There are three angles here. What are the angles here, students? That in triangle ABC, what are the angles, students? That is the angle ABC and angle comma angle ABC, after that angle BCA, after that angle CAB. So these are the three angles. How many angles total? Three angles in a triangle. So in these intersecting lines, what are the lines? Intersecting lines. Intersecting lines. So there are two lines here which are intersecting. Okay, students, how many angles? There are four angles. What are the angles, students? That is angle PO. So not only four, students, yes, students, four angles. There will be four angles. Angle POS is one angle, comma angle POR is another angle, comma angle ROQ is another angle, angle QOR, so QOS is another angle, students. Okay, so this is the one angle, this is the another angle, this is the another angle, this is the another angle, students, like that. So in the case of angles also, we have studied previously about there may be acute angles. What are acute angles, students? If the angle is less than 90 degrees, we say that is the acute angle. And there are obtuse angles. What are obtuse angles, students? Obtuse angles. So if the angle is greater than 90 degrees, we say those are obtuse angles. And what are right angles, students? Right angles. Angle is equal to 90 degrees. Suppose this is between these two rays, the angle is 90 degrees. Between these two lines, the angle is greater than 90 degrees. And between these two rays, the angle is less than 90 degrees. So this is the acute angle, and this is the obtuse angle, and this is the right angle. So these are the two arms or the two sides, and this is the vertex, and this is the angle. So this is the knowledge we have studied in the previous classes, in the previous chapters, students. So this is the basically what the introduction here it is. So now we will discuss about related angles. So in this concept we are going to understand about some angles. So first thing is about complementary angles. Complementary angles. So what are complementary angles, students? Can you understand? So now I will give you some examples. Observe these two angles. Here the angle is 30 degrees. Here the angle is 60 degrees. So now observe these two angles. Here the angle is 35 degrees. Here the angle is 65 degrees. So just add these two things. How much you will get? 30 plus 60. 30 plus 60. That is equal to 90 degrees. In this case also 35 plus 65. How much? It is also 90 degrees. So what are complementary angles? So whenever if two angles are added, if the total resultant angle is 90 degrees, sum of angles or sum of two angles, if sum of two angles is 90 degrees, then we say those are the complementary angles, students. Okay, if sum of the measure of two angles, sum of the measure of the two angles is 90 degrees, then the angles are complementary angles, students. Okay, so this is a complementary angle. Why? Because this angle and this angle, if you add both these angles, you will get 90 degrees. In this scenario also, these two angles, whenever you are adding these two angles, you are getting 90 degrees. So these are the complementary angles, students. So whenever two angles are complementary, we say that each angle is complement to the other angle, students. So sum of two angles is 90 degrees. We call this as the complementary angles. and each angle, and one more thing you have to remember is each angle is complement to another angle, oh sorry students, another angle. Okay students, so here 30 degrees is complement 30 degrees angle, or we can see there is no naming for that angle, no students. So 30 degrees angle is complement to 60 degrees, and vice versa. 60 degrees angle is complement to 30 degrees angle. That's it students. So these are called complementary angles. If sum of two angles is 90 degrees, 90 degrees, 90 degrees, then we say both angles are complementary angles. Next thing is about, so now just try this. So whether these two angles are complementary or not. Here the angle is 70 degrees. Here the angle is 20 degrees. Whenever we are adding 70 plus 20, it will give rise to 90 degrees. So these are the complementary angle students. Oh, now in this case, this is one angle, this is another angle. So 35 degrees plus this is 55 degrees. So whenever you are adding two angles, 55 plus 30, that will also 90 degrees. So it is also a complementary angle. 75 plus 25, it is not a 75 plus 25, it will give 100 degrees. So these two are not complementary angles, in this case also these two are also gives the 100 degrees. So these are also not complementary angles students. Okay, what is the measure of the complement of each of the following angles? So here he has given one angle, that is 45 degrees. So what is the complement angle of 45 degrees? I have told you one point. No, what I told you, each angle is complement to another angle. So if 30 degrees is complement to 60 degrees and 60 degrees complement to 30 degrees. So for 45 degrees, what is the complement angle? We need totally 90 degrees. So 45, another angle is 45. So that these two will becomes complementary angles. Next, here what is the complement of 65 degrees angle? That is the complement of 65 degrees angle is 25 degrees. 60, 20, 80 plus, so 625 degrees is the complement angle. Why? If you add both these angles, you will get 90 degrees. Similarly, you have to do for this also students. So that is about complementary angles. Now we will discuss about supplementary angles. So what are supplementary angles students? Supplementary angles. So look at the figures. So here there is a 60 degrees, here there is a 120 degrees. And look at this figure. Here is the 68 degrees, here is the 112 degrees. What happened if you add? So if you add 60 degrees plus 120 degrees, it will give how much? Whether it will give 90 degrees. If it gives 90 degrees, then we say those are the complementary angles. But here it is not giving 90 degrees, but it is giving 180 degrees students. So in this case, it is a 68 degrees plus 112 degrees. So 112 degrees. So what happened when you add these two things? So 112 plus 8 is 120, 120 plus 60 is 180. Here also 180 degrees students. So whenever we are adding two angles, it is giving 180 degrees. No. So in this case, we call these are the supplementary angles. So what are supplementary angles students? So when two angles are supplementary, each angle is said to be supplement to the other. So simply, what are supplementary angles? If two angles, if the measure of sum of two angles, is 180 degrees, then we saw that there is the supplementary angle students. And similar to complement angles, we say that each angle is supplement to another angle students. another angle. Okay students, if you want an example, suppose 60 degrees is supplement to 120 degrees students, and 120 degrees is 120 degrees angle is supplement to 60 degrees students. If anybody asks you, if anybody gives one angle, and if anybody suppose if anybody asks you the question, suppose if anybody have given you some angle like suppose x, or simply if anybody gives you some 75 degrees, okay students, and he asks you what is the supplement angle for it, then what you have to do, you have to subtract this angle from the 180 degrees. So that is 180 minus 75. The answer will be what students? 180 minus 75. How much? That is 105 degrees. So finally, what is the supplement angle for 75 degrees? That is 105 degrees angle. So in this way, you have to answer those questions, students. Okay. So that is the thing. So here there are two angles. These two are also supplement. Why? Supplement means 100 degrees plus 80 degrees. That is 180 degrees. So supplement. Here also they are 140 plus 30, 170. Here also supplement angle, students. Okay. So there is an example. 130 plus 50. So these two are the supplement or not? So 110 plus 50. It will give us how much? 160. So these are not equals to 180. So these are not supplement angles, not supplementary angles. Here 105 plus 65. It is giving 170 only. Not supplementary angles. 45 plus 45. These are not supplement angles. These are complement angles. Complementary angles. Not supplementary angles. Here 130 plus 50. So it becomes 180 degrees. So it is a supplementary angle, students. Okay. That it is, students. Next thing. So what will the measure of supplement of each of the following? So what is supplement angle for 100 degrees, students? That is obviously what I told you, subtract this value from 100. So some 180 minus 100 will give us the 80 degrees. So this is the answer. In this way, you have to subtract every angle from 180. That's it, students. So now we are coming across the adjacent angles. So what are adjacent angles, students? So before I telling you, I want to observe these figures. So this is the angle A and this is the angle B, and there is an angle and there is an angle and there is an angle. So these two are called the adjacent. These are called adjacent angles, friends. So why you are calling those are the adjacent angles? So for adjacent angles, there is a there are some qualifications, students. If two angles are adjacent, they must have common vertex. If two angles are adjacent angles, then they must have common vertex. They must have same vertex. Here this angle A and this angle B have the one vertex, common vertex, and also this angle, all these are having the only one vertex. This is like that. So all the two angles must have the same vertex. And one more thing is they have a common arm. They must have a common arm or common side. Okay, students. If you see, this is one angle, this is another angle. For these both angles, this angle is common. This side is common. This arm is common. So if you take this angle and this angle, so for these two angles, this is common. So this is the angle and this is the angle. So this is the angle A and this is the angle B. So this is the common side for both angles A and B. So if two angles are adjacent, they have common arm and they have common vertex. And what is the another thing? The non-common arms are on either side of the common arm. So non-common arms. So one common arm, that remaining there will be two other non-common arms. Though, so that non-common arms or the sides are must be on either side of common arm. So this is one more condition, students. Okay, suppose I will explain you. So what happens in this case only? So this is one angle and this is angle A and this is angle B. So there must be a common vertex like this. There must be a common common arm or common side like this. And next thing is, what is the third condition? This is the common arm, and this are the non-common arms. So these non-common arms are on the either side of the common arms. So this is the common arm, and non-common arms must be on the either side of the common arm. Suppose this is one angle A and this is another angle B. Does these both angles are adjacent angles? So now check common vertex. So for angle B and angle A, both are having common vertex and common arm. So for angle B, this is the arm, and for angle A also, this is the common arm. So this is the common arm. Now we will check for non-common arms. What are the non-common arms? This is non-common arm. This is non-common arm. What is the condition? Non-common arms are on either side of the common arm. So for common arms, they will be on either side. So for this side, there is non-common arm, but this side, there is no non-common arm. So these are not adjacent angles, not adjacent angles, students. Angle. So but here they are adjacent angles. So this is what the third condition itself, students. I think we have understood it. Okay, students. So here angle 1 and angle 2, thus these are the adjacent angles. So both angles are having the common vertex and both are having common arm, and this is common arm, and non-common arms are on the either side of the common arm. So finally it is a adjacent angle. Next, angle 1 and angle 2. So both these angles are having common arm. Okay, one point is, next thing is common vertex. It is finally succeed. Next thing is common arm. So for this angle, this is the arm. For this angle also, this is the same arm. So this is the common arm. And what are the other arms? Non-common arm, non-common arm. So according to third point, non-common arm are on the either side. So for common arm, this is one side, this is the another side. So it is also a adjacent. If you take this, so for this angle, vertex is here. For this angle, the vertex is here. They are not having common vertex. So it is not. These are true. These are true. True means adjacent angle. This is not. Why? Because the first condition is not satisfied. But they are having a common arm. So this is the common arm. No. So they are common arm. And these are the common, non-common, non-common. And non-commons are both sides of the common arm. But first condition is not satisfied. They are not having the same vertex, students. So in this way, we have to find out the adjacent angle, students. Okay. Adjacent angle. So in this figure also, in the figure 5.10 are the following angles. So these two angles are adjacent or not? What is the angle? Angle AOB, angle AOB. So this is the one angle, and angle BOC, angle BOC. So these two are the adjacent angles or not? Yes, these two are the adjacent angles. Why? They are having the common vertex O, and they are having the common. So we will justify the answer, students. They are having common vertex O, and they are having common arm. What is the common arm? B is the common arm, and they are having non-common arms A and C on either side of B. Either side of B. So this is the common arm for these two angles, and these are the non-common arms, and these non-commons are on either side. So this is the adjacent angles. Now coming to BOD and BOC. Now we'll come to these, students. BOD. So this is the angle, and BOC. So this is the angle. So this is the first angle. This is the two angle. So for the both angles, vertex is 0. Okay, first condition is satisfied. Next condition is common arm. So for the both things, what is the common arm? So this is the common arm, but third condition is not. Why? Because this is the non-common arm and this is the non-common. There's a one side of the common arm. So these are. So this is not. So this is not. Second B option is not correct, which means it is not a adjacent angle, students. Okay. Next thing is about linear pair. What about, students? What are linear pair? Linear pair of adjacent angles. So linear pair of adjacent angles. So we have understood what adjacent angle is. Now a linear pair is a pair of adjacent angles. So a linear pair is nothing but a pair of adjacent angles. So if you see a word called linear pair, then you have to strike with one word in your mind, that is called adjacent angles. So for the case of adjacent angles only, we will discuss about linear pair. So a linear pair is a pair of adjacent angles whose non-common sides are opposite rays. So what is the condition? First condition for linear pairs are they are adjacent angles. So just I will rub these, students. Okay, linear pair. For linear pair, there are adjacent angles. First thing, first condition. Next thing is their non-common arms must be opposite. Must be opposite. Okay, students. So we know in the adjacent common vertex, they will must have common vertex and common arm, and non-common arms are on either side of common arm, like that. So what is the next condition for linear pair is that non-common arms must be opposite. Take this example. So these two are the adjacent angles or not. So these two are having the same vertex. So first condition is satisfied. And these two are having the common vertex. So common arm. So satisfied. Next thing is these two, the non-common arms are on the either side of the common arm. Okay. Finally, these are the adjacent angles. So they are eligible to become a linear pair. But there is one more condition to be satisfied, that non-common arms must be opposite. So what are the non-common arms? So this is the non-common arm, this is the non-common arm, and if you see clearly, both these are opposite to each other. So finally, these are linear pair. These may become linear pair. So one angle is this, another angle is this. This is the common arm. Okay, students. Angle 2, angle 1. So this is an example of linear pair. Why? Because this is the common arm and this non-common arm are opposite. So this is the example, students. If you take this, does this a linear pair? So first adjacent angles are not. So common vertex, okay. Common arm, okay. Non-common arms, okay. But what is the condition? Non-common arms must be opposite. But these are not opposite. This is in this direction, this is in this direction. So if it is in this direction, then they will be common arms. So these are not linear pair, students. Okay, they're not linear pairs. Observe that the opposite rays which are non-common sides of angle 1 and angle 2 from a line, thus angle 1 plus angle 2 amounts to 180 degrees. So here angle 1 and angle 2 will gives rise to 180 degrees, students. So finally, what we conclusion? So whenever the condition of linear pair, in the case of linear pair, both the angles, angle 1 and angle 2 is equals to 180 degrees. Why? Because means the non-common pairs are opposite to each other. So they are in like a straight line. So they will form a straight line. The angle in the straight line is 180 degrees. So therefore, what is our conclusion is angles in linear pair. Angles in linear pair are what? There are supplementary angles, friends. Okay, that is the thing you have to remember, friends. Okay, note carefully that a pair of supplementary angles form a linear pair when placed adjacent to each other. So if you can find these, students. Okay, now these are the real life examples. So here what happens? This is the angle, this is the angle. Two angles have a common vertex and common arm, and non-common arms are opposite to each other. So these are linear pair. So and the angle here is a supplementary angle 180 degrees. So this is also same angle, same vertex, same common arm and opposite non-common arms. So here also the same, students. So in this case also, this is the common arm, same vertex, non-common. So they are the linear pair. So this is not linear pair. So this is linear pair. Why? This is the non-common, this is the non-common, both are opposite and they are making angle of 180 degrees. So this is common, so linear pair. Like that, students. Okay, we have to solve those examples. So after that, vertically opposite angles. So what are vertically opposite angles? Suppose if you take two pencils and tie with a rubber band like that. So what happened if there are two pencils like that? So between here there is an angle, here there is an angle, here there is an angle, and here there is also angle. So here that is angle 1, angle 2, angle 3 and angle 4. If you clearly observe that angle 1 is opposite to angle 3. Okay, student, angle 1 is vertically opposite to angle 3. And one more thing is angle 2 is also vertically opposite to angle 4. Okay, student. So we call angle 1 and angle 3 are pair of opposite angles. So angle 1 and angle 3 are pair of opposite angles, and angle 2 and angle 4 are also pair of opposite angle, students. Oh, sir, why, sir, means let's check. So these two are opposite, vertically opposite. That's why we call as the vertically opposite angle, students. Okay, so before checking this, we see some more examples. So here, these two are the vertically opposite angles. 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 Here also, these two are the vertically opposite angles. These two are also vertically opposite angles, students. Okay, so now draw two lines L and M intersecting at a point. So you have to draw two lines. Lines. This is L and this is the M. So intersecting at a point, they're intersecting at a point. You can now mark angles as in figure 5.16. You have to mark the angle 1, angle 2, angle 3, angle 4 like that. Take a trace copy of the figure on a transparent sheet. Place the copy on the original and take a trace copy of this. And what we have to do such that one matches with its copy, two matches with this copy. Fix a pin at the point of intersection. Now we have to fix, after taking a trace copy of it, after placing the original, fix the point at this. And what you have to do is you have to rotate it. You have to rotate 180 degrees. Trace copy rotated 180 degrees. So what you will observe is you have to rotate that rotate such that how you have to rotate is that angle 1 must coincide with angle 3 like that. So you will find that angle 1 and angle 3 have interchanged their positions, and angle 2. So whenever you are rotating it like that, can be rotated to get in this way, you will observe that angle 1 have interchanged their position with angle 3, and angle 2 is interchanged with angle 4, students. And one more thing is you observe after rotating the trace paper like this, that angle 1 and angle 3 are equal, and angle 2 and angle 4 are equal. So finally what we can conclude that vertically opposite angles are equal, students. Okay, we can conclude that when two lines intersect, the vertically opposite angles so formed are equal. So finally vertically opposite angles are equal. So whenever two lines are intersected. So now we can prove it geometrically. So take two lines L and M. Okay, students, suppose take this line L, M, and this is the angle 1, angle 2, angle 3, angle 4. Now we'll do it geometrically, students. Okay, what is our aim? We have to prove angle 1 equal to angle 3 and angle 2 equal to angle 4. So now angle 1 is what? Now we will write angle 1 is equal to how much? Take this line and this line, students, like that. So angle 1, you have to write angle 1. So angle 1 is how much? So this is a straight line, M is a straight line, so total angle is 180 degrees. 180 degrees minus, so what is this angle? This angle is angle 2. So you have to write this angle 2, no, angle 2. So this is the first case, angle 1 equal to 180 degrees minus angle 2. Now observe it for angle 3. How we can write angle 3? Angle 3 is equal to, so angle 3. Okay, students, angle 3. So here this is the angle 3. How we can write it is, this the total angle is 180 degrees because it is a line M. So 180 degrees minus, what is here the angle is angle 2. So if you clearly observe these two things, right hand side is equal, so we can equate left hand side. So finally angle 1 is equal to angle 3. So we have proved geometrically that vertical angles, vertically opposite angles are equal. Similarly, you can prove angle 2 equal to angle 4 also, students. That's it. In the figure given, if angle 1 equal to 30 degrees, so suppose if this angle is 30 degrees, so find angle 2 and angle 3. So you have to find angle 2 and angle 3, students. How you will find? So according to vertically opposite angles are equal concept, so the vertically opposite angle is 3, so finally angle 3 is also 30 degrees. So after completing it, so suppose just take this line alone, you take this line alone only, so that this is making 30 degrees, and we know this is a straight line, so it will have 180 degrees. And what is this angle? This angle is nothing but 180 degrees minus 30, so that will becomes 150 degrees. So finally angle 2 is 150 degrees and angle 3 is 30 degrees, friends. That's it. So here is an example, students. We have to identify 5 pairs of adjacent angles. So these two are the adjacent angles, students. Why? Because these two are having the same vertex, common arm and non-common arms. Common, non-common, all opposite side. So finally what I said is these two are the one pair, and these two are another 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 pair. So now I will name it, students. So first angle, first pair. Next thing is second pair, second pair of common angles. Next thing is third pair. Oh, wait a second, students. Third pair. Next thing is about fourth pair. Fourth pair. Next thing is about fifth pair. So finally 5 pairs. You have getting 5 pairs, students. 5 pair of adjacent angles. Here they have given 3 linear pairs, but 3 linear pairs are not possible, students. Only 2 are possible. So if you draw the diagram here, so linear pairs means the opposite, the non-common angles. So these are the, out of these 5 adjacent pairs, there will be only two. So the angle, this angle, this angle and this angle, okay, students, are the linear pairs. Suppose I will explain you. Here what are the numbering here? Here it is the A, and here it is the O, and here it is the B, and here it is the C, here it is the E, and here it is the D. So what are the linear pairs here? Linear pairs. Basically there are 5 adjacent angles. So upon 5 adjacent angles, we have to choose only the adjacent angles whose non-common arms are opposite. So these two non-common arms, these are the two common arms, and this is the angle. So what are the linear pairs? That is angle COB and angle AOC. Angle AOC and angle COB having non-common arms. Next thing is about angle EOC and angle DOE. Okay, students. And next thing is, so that's it, students. And if you want, you can form another one also, students. This is angle D, angle AOC, comma angle AOD. So these are the 3 pairs, students, but in your textbook they have given only 2 pairs, students, but we have find out here also they have given 3 pairs, students. Sorry. So finally we have find out the 3 pairs of linear pairs. Next thing is 2 pairs of vertically opposite angles. So what are the vertically opposite angles? So this angle and this angle are opposite, and this angle are opposite. I will write the opposite angles. Opposite angles, vertically opposite angles. Angle COB and angle AOD is the opposite angle, students, like this. So this, and wait a second, students. So this is the thing. Next thing is, this is the thing, Next thing is this line. Okay students, so this and this are the opposite angles. So we are writing a, here it is the name as C, it is the name as B, and it is the name as O, and it is the name as E, and it is the name of A, and it is the name of D. So angle COB and angle AOD are the opposite angles students. Next pair of vertically opposite angles are, what are those students? Carefully examine with me that we can write angle AOB and AOC students. Okay, we can write DOB or angle BOD, angle BOD. Okay students, next thing is angle AOC, angle AOC, angle AOC. That's it students. So these two are the opposite angles. Can you observe this students? This angle and this angle. I'm giving two slashes so that you can observe. So these are the opposite angles students. So in this way we have to find out the opposite angle students. So finally what happens students? We have completed our topic students. Hello students, now we will discuss pair of lines. In that pair of lines, intersecting lines, next transversal, angles made by transversal of a parallel lines, and after that checking for parallel lines. So these are the concepts we are learning in this video students. So now we'll start with the pair of lines. So in this students, first we are going to discuss about intersecting lines. So what are intersecting lines students? So carefully observe the diagrams below. So there is a backboard, so it is in this direction, and there is a line in this direction. And if you observe, to support the blackboard, there are behind it there are the wood structure which is like that, and this case of alphabet Y, and this case of this. So what happens, we know lines, intersecting lines. So this is called the intersecting lines. When two lines are intersected, or when two lines are cut each other at one point, we call these lines as intersecting lines. Line L, line M, maybe the point as intersecting point is the P. So these are the intersecting lines. Okay students, and this common point, we call that common point. What is that common point students? That is the intersecting point. Intersecting point students. So we will see many times in our surroundings intersecting lines. So intersecting point. So in this diagram, these two are the intersecting lines, and this is the common point. And this diagram, there are so many intersecting lines, and there are so many points. Okay students, so like that, intersecting points, intersecting point is the common point when two lines intersect or cut each other. Okay students, that is about intersecting lines, and those are the intersecting lines of examples. So the common point is called the intersecting point, or another name is point of intersection. What is students? Point of intersection. Point of intersection students. Okay, can you understand it? Yeah. Now suppose if this is the just think and discuss. So in this, what are the intersecting lines? So there are so many intersecting lines. So this line is intersecting, so here B is the intersecting point of these two lines. That line is BC and BP. Okay students, and the C line and the E line will intersect at this point C. So this is one intersecting point, this is another intersecting point. These two are the intersecting lines, these two are the intersecting lines. And if you see, these two are also intersecting lines. Okay students, and if you see, these two are intersecting lines here, and these two are intersecting lines here. So that we are getting so many intersecting lines and intersecting points in here students. So try to find another 10 pairs of intersecting line segments. So in figure 5.20, AC and BE are intersected point P. So this AC and BE intersected a point P. That is the intersecting point, common point. Okay students, okay, now AC and BC intersect at C. Okay, this AC and BC will intersect at P. This is another intersecting point. Next thing is AC and EC. AC and EC will intersect at C. So this is another intersecting point. So try to find out another 10 pairs of intersecting line segments. So in this way, I have told you 3 pairs, no, and one more thing, 1 or 2 pairs also. In this way, try to find out the 10 pairs of intersecting lines, students, line segments. Okay, students. Should any two lines or line segments necessarily intersect? Can you find 2 pairs of non-intersecting line segments in the figure? So study from this thing. Can you find any non-intersecting lines? Okay, students. So that is your work. You have to do it, students. Okay. Now next thing is about transversal. So what is transversal, students? What we call as transversal? Just see the example. Sometimes you see that a single road will cross or cut 2 roads, and these 3 wood strips are crossed by or cutted by this line. So what is a transversal? Transverse is nothing but it is a line that intersects. What is the transversal? Transverse is a line. What is the special qualifications for that line? So that line will intersect 2 or more other lines, 2 or more lines. So basically transverse is a line. It will intersect 2 or more lines at distinct points, is called a transverse. Suppose this is a transversal line M. So what is the condition? This line must intersect 2 lines. So this may be 1 line and this may be another line, 2 lines at distinct points. So this transverse is intersecting this line at this point, and this transverse is intersecting this line at this point. So these 2 points, these 2 intersecting points are distant and separate points. So if you intersect 3 lines, here it has intersected 3 lines, but it is intersected these 2 lines at the same point. So suppose if there is no line like that, and suppose this is a line and it intersecting 2 lines, but it is intersecting at the only 1 point, then it is the transverse line? No, not at all. So what is the condition for a transverse line? It must intersect 2 lines or 2 or more lines at different points, like that. So we will get distinct points. So it must not intersect at the same point, like that. It is not possible. So in this case, we call this line, which is the line which is intersecting 2 or more lines at different instances. So if you see, this is the line. It is intersecting this line at this point, this line at this point, this line at this point. So it is a transversal line. And in this case, this is the road. This road is intersecting this road at this point, this road at this point. So it is a transversal line, students, or the transversal. So that is thing about transversal. So here L and M are 2 lines. L and M are 2 lines. So there is a transversal P. So which is intersecting first line at some point, second line at some point. So this is a transversal. But it is not a here P is not a transversal. So it is intersecting even though 2 lines, but at the only one common point it is not. So this is called, students, transversal. I think you have understand about transversal. Next is the angles made by a transverse. Okay, transverse is a line. It will intersect 2 lines at distinct points. Now whenever it intersects 2 lines, it will make some angle. So previously what I have discussed, when there are 2 lines intersected, there will be angles. No, so here what happening, 1 line is intersecting 2 other lines. So in this case also there will be angles. So now we will study the angles made by transversal. Angles made by the transversal. Okay, students. So now just to see, this is a transversal line and it is intersecting 2 lines. This is the line M and this is the line M, this is the line P, intersecting, sorry, transversal line. So what happens, just forgot this line, just take this line and this line. So when our 2 lines intersecting, they will form angles. So this is the angle, this is the angle, this is the angle, this is also angle. So now name the angles. Let it be 1, let it be 2, let it be 3, and let it be 4. Now remember this L line, just remember the P line and the M line. So when our 2 lines intersect, they will form angles. So this is the angle, this is the angle, this is the angle, this is the angle. So now also name the angles. This is the 5 and this is the 6 and this is the 7 and this is the 8. So finally, whenever a transversal is there, whenever it is intersecting 2 lines at different points, it will forms angles. These are the angles formed by a transversal, students. So in these angles there are some kind of angles. What are some kind of angles? They are corresponding angles, and there are alternate angles, and there are interior angles, and there are exterior angles, and pairs of interior angles on the same side of the transversal. So these are the different angles we are having, students. Okay, and interior angles, and so pairs of alternate angles and interior angles, alternate angles in external angles. So I will explain you clearly about all those, students. So now come and join with me. So just if you see, observe these things. So this is a transversal, these are the intersecting lines. Suppose this is the transversal and this is the intersecting lines. So here there is an angle 1 and there is an angle. Now I will start my discussion with interior angles, students. So what are interior angles? So these are the two lines, and what is the interior part here? Interior means which is behind these two lines, that is the exterior. And what is the exterior? So which is above this and below this is the exterior. So interior angle means the angles are in the inner side. So what is the inner side? So this area is the inner side, inner. So this is the external. So this is also external to these two lines. So what are the angles here? What are the interior angles here? So this is the angle which is an interior angle, this is the angle which is an interior angle, this is the angle which is an interior angle, this is the angle. These are the interior angles. So what are names we have given to it? And the example 1 2 3 4, no, 4 5 6. So these are the interior angles. Now what about exterior angles? So exterior means which are outside. So this is the line. So students, this is the line. So this is the inner area. What is outer external area? That is, so this angle are exterior angles 1 2, and these two are the exterior angles. So these are 7 8. So these 4 angles are the exterior angles, students. So have completed what are interior angles and what are exterior angles. So in the interior angles and exterior angles there are some different angles. They are corresponding angles also. Corresponding interior angles and corresponding exterior angles, but I will explain you all at a time. So this is the thing. So this is the exterior angle and this is the interior angle. So these two are the corresponding angles. Why? Because for this line it is on this side, for this line it is this one. So they are the corresponding angles, and some other corresponding angles are, this is also corresponding angle. Okay, students. And what are the other remaining angles? I will draw another diagram. So this and this also corresponding angle, and this and this also corresponding angle. So what are the names? 1 2 and is the 5 and 6. So what are the pair of corresponding angles? Angle 1 and angle 5, angle, or we can say angle 1 comma angle 5 are pair of corresponding angles, and angle 2 comma angle 6 are pair of corresponding angles. And here it will become 3 4 and it will become 7 8. So here also angle 3 and angle 7, which are on the same position to the same line. No, so these two are the pair of corresponding angles. In this case angle 4 and angle 8 are the pair of corresponding angles. Now we will consider the alternate angles. What are alternate angles? Alternate angles, alternate means which are like alternating. No, so suppose now we'll consider about alternate interior angles. We will discuss about alternate exterior angles. Okay, students, alternate. So interior angles are angles in this area. So what are alternate angles? So here angle, here angle, here angle, here angle. So what are the names? Here it is the 3 and it is the 4 and it is the 5 and it is the 6. So if it is on the same side, they are not alternate. So this angle and this angle are the alternate angles. So angle 3 comma angle 6 are alternate interior angles, and similarly angle 4 comma angle 5 are alternate interior angles. Now coming to the exterior angles. So here there is an angle and there is an angle. So these two are the alternate exterior angles, angle 1 and angle 8. So angle 1 comma angle 8 are alternate angles and exterior angles, and here angle 2 and here angle 7. So angle 2 and angle 7 are alternate exterior, alternate interior angles, friends. So we have discussed about alternate interior angles, alternate exterior angles, corresponding angles, and interior angles and exterior angles, students. So in this figure, if you see, so these are the corresponding angles, corresponding angles, corresponding angles, and these are the alternate angles, alternate interior angles, like that, students. So alternate interior angles having different vertices, so they are having different vertices, are on opposite side of transversal. So alternate angles are on the opposite side of the transversal and lie between the two lines. So interior angles, so that's why they are lying between the two lines. What are the conditions for corresponding angles, friends? So for corresponding angles, they are at different vertices. If you see at this vertex, 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 all are different vertices. Suppose if there is this angle, so these two are having at the same vertex. So but here two vertices, no. So this is the meaning of different vertices. And one more thing, are on the same side of transfer. So these two angles are on the same side, this side, and these two are also the same side, and these two are this side, these two are inside side of the transverse, or in corresponding positions. So they are in the corresponding positions, that is it is on above, it is on above, and it is on below, it is on below, it is on right side above, it is on right side above, it is on right side below, it is also right side below, like that, friends. So these are the conditions for corresponding angles, and these are the conditions for interior angles, friends. Okay, you have understood. Next thing is what? Pair of corresponding angles we discussed, exterior angles we discussed, interior angles we discussed, pair of alternate interior angles we discussed, pair of alternate exterior angles we discussed. We not discussed pair of interior angles on the same side of the transversal. So for the same side of the transversal means, suppose I will explain you, students. So let's take here. So pair of interior angles. What are the interior angles? This. All these are the interior angles. And pair of interior angles on the same side. So this is one side and this is another side. So this is the 3 and this is the 4 and this is the 5 and this is the 6. So angle 3 comma angle 5 are the pair of interior angles on the same side. So and one more thing is angle 4 comma angle 6. These are on the other side pair of interior angles. That's it, students. So whenever there is a transversal which is cutting two lines, we are having this type of angle, students. Okay. So now by observing this, can you tell what are those angles? So these two angles are what? Whether these two angles are corresponding angles, alternate angles, alternate internal angles, alternate exterior angles, pair of interior angles on the same side, or like that. What are those, friends? So basically they are at different vertices, and one more thing, they are at different vertices and they are on the corresponding side, and they are on the same side and corresponding side. So they are the corresponding pair of corresponding angles. So if you see here, both are the in the interior angles. So and both are in the alternate positions. So alternate interior angles. So in this case, what happened? These also the on the interior and these also the same side. So we call this as the pair of interior angles on the same side of transversal. And these are what? These are on the same side of the transversal, and these are the different vertices, and these are the corresponding positions. So corresponding angles. These are the alternate interior angles. These are what? These are supplementary angles, friends. Whenever we say supplementary angles and adjacent angles, also we can say supplementary angles and adjacent angles. And even though we can say these are the supplementary angles, these are the adjacent angles, these are the linear pair of angles also. There's so many names. Why? Because non-common sides are opposite. So linear pair, and it is having common same vertex. So adjacent. And whenever two angles are equal, they give 180 degrees, like that, friends. So next thing is about transversal of parallel lines. So we know what are parallel lines. So these are parallel lines. If you see the railway track is like that, no, students. So these two lines are the parallel lines. So the lines which will not meet at any point are called, which will not intersect at any point are called parallel lines. So now if you take parallel lines and if you draw a transversal to a parallel line, and what are the angles in this case? So we know the angles are similar, this. So 1 2 3 4 5 6 7 8. So 1 and 5 are corresponding same, and 3 and 7 are corresponding, and 1 and 8 are alternate exterior angles. So all the stuff we have discussed about. So now what we have to do, take a trace paper over the figure drawn, and what we have to take, trace the lines L, M and T, and slide the tracing paper along T. So this is the T, and this is the L, and this is the M. So we have to slide the tracing paper along T until the L coincides with M. So finally what you observe is that by doing the tracing paper experiment, you will observe that angle 1 is equal to angle 2 whenever it is moved towards to this. If in fact you can see all the following results by similar tracing and sliding, that angle 1 is coincides with angle T. So basically here students, the angle 1 is here and the angle 2 is here. So numbering is not like that. So we can change numbering, or if you keep this numbering also no problem. So if you trace like that, what you will observe is angle 4 is equal to angle 8, or one more thing is angle 2 is equal to angle 6. This will you observe when you are tracing this towards sliding towards downward. Okay students, so finally, but here the numbering is different, so for your clarity and understanding we'll change the numbering students. Okay, we'll change the numbering so that you can easily understand. By this also you can understand, but it will be somewhat confusing. So here the angle 1, and here the angle 2, here the angle 3, here the angle 4. So for every experiment, every diagram they are changing. So finally here angle and here angle are equal, which means corresponding angles are equal, and these two are also equal. So these two are also equal, so which means corresponding angles are equal, and these two also equal. We have already discussed it. So finally what we can say is that if two parallel lines are cut by a transversal, each pair of corresponding angles are equal. So these two are also equal, and these two are also equal. So finally what is the condition is, in the if transversal cuts parallel lines, what is the first thing you have to remember? First result is that in this case what happens, each pair of corresponding angles. What are the things students? Corresponding angles. Each pair of corresponding angles are equal. This is the one thing you are observing students. Now we will do another thing. So we use this result to get another interesting result students. So when T cuts the parallel lines L and M, we get angle 3 equal to angle 4, angle 3 equal to angle 7. So verify vertically opposite angle. So in this case, suppose if we take 1 2 3 4 and 5 6 7 7 8 like that. Now students, the diagram is different. See figure 5.29. So if you see this figure, and these two angles are equal. Why? Because means they are the vertically opposite angles. Vertically opposite. We know vertically opposite angles are equal from previous knowledge. But angle 7 and angle 8 are corresponding angles. So what is the thing? But angle 7 and angle 8 are corresponding angles. So we know angle these two angles are corresponding angles are equal. So we know these two, angle 7 is equal to angle 8 corresponding angles. And here angle 3 equal to angle 7. Why? Because means opposite angle. So finally what is the conclusion? Angle 3 equal to angle 8. So from this what happens? Alternate internal angles are equal. So alternate internal angles, internal angles are equal. Okay students, so what we can consider it? So finally what is our second result? Here we got the first result, each pair of alternate corresponding angles are equal. Here we are getting second result, and even though angle 1 is equal to angle 6. So if two parallel lines are cut by a transversal, each pair of alternate internal angles are equal. In this case, what happened? Each pair of alternate internal angles, alternate internal angles are equal. Each pair of alternate internal angles are equal. So this is the case, students. This is the second output you have to remember. So using these two results, so finally what is our conclusion? We conclude that these alternate corresponding angles are equal. What is the one thing? And next thing is internal angles are equal, alternate internal angles, by using these two results. So again, angle 3 plus angle 1 equal to 180 degrees. We know these two are equals to 180 degrees, and angle 1 equal to angle 6. These two are equal. So sorry, these two are not. So these two are equal according to what? According to second relation. So what happened here, students? Angle 3 equal to angle 1. Sorry, angle 3 plus angle 1 is equal to 180 degrees. And we know that angle 1 equal to angle 6. Therefore, angle 3 plus angle 6 equal to 180 degrees. So finally, what is our conclusion? Angle 3 plus angle 6 equal to 180 degrees. So what is the conclusion is, whenever there are two angles are 180 degrees, we say that there are the supplementary angles. So where the angle 3 and angle C, they are on the same side, internal angles same side. So this leads to the third result, that is, whenever the two parallel lines are cut by a transversal, then each pair of interior angles, what are those? Interior angles on the same side of transversal are supplementary. Okay, students. So this is the thing you have to understand. So each pair of interior angles on the same side of transversal supplementary, students. So that is thing. So what happens finally? So these two are equals to 180 degrees. These two equals to 180 degrees. So this is called supplementary. So finally, if a transversal cuts the parallel lines, we are getting three results. One result is corresponding angles are equal, alternate internal angles are equal, and the internal angles on the alternate angles on the same side of the transversal are supplementary. So in this figure, we can represent corresponding angles by F. Can represent corresponding angles by letter F. So this F represents this F corresponding here, the corresponding. So corresponding angles, and alternate angles by Z, letter Z. So here the Z, alternate internal angles. So all these are equal, students. Okay, so finally we can say, so we can represent alternate internal angles by Z and corresponding angles by F, Z. So now we will checking for parallel lines. So this is the next concept. So how to check parallel lines? Checking for parallel lines. So how to check for parallel lines, students? If there are two lines given, and if anybody asks you whether these two are parallel lines or not, then how we can check it? So there is very simple, students, to check. So we know three results. So if parallel line cuts, if parallel lines, or if transverse cuts parallel lines, if transversal cuts parallel lines, then what are the three conditions, students? First thing is corresponding angles are equal. Next thing is alternate internal angles are equal. Next thing is internal angles on same side of transversal are supplementary or simply 180 degrees. These are the equal. So if what we know from the previous knowledge is, if there is a transversal, if it will cut the parallel lines, then these are the outcomes. These are the outcomes, friends. So if you want to check whether the two lines are parallel, simply if you find the corresponding angles are equal, then the two lines are equal. And if you check whether the alternating internal angles are equal like this, then the two lines are parallel. If the internal angles on the same side, these angles on same side are equal to 180 degrees, in this case also they must be parallel. So if it satisfies these three things, then we say that those two lines are parallel lines. If in the case of if anybody gives you two lines and they have given you a transversal and he asked whether the two lines are parallel or not, then you can simply find these three things: observe or check whether the corresponding angles are equal or not, each pair of corresponding angles, then it is parallel lines. And observe each pair of alternate angles are equal or not, then it is parallel. And observe each pair and some internal angles on the same side of transversal are 180 degrees or not. If all the conditions are proved, all these are satisfied, then those two lines are parallel lines, friends. Very simple. Okay. And one more thing is, corresponding angles are represented by letter F and alternating angles are simply by Z. So these angles are equal, like that. So using this also you can find out whether the angles are equal or not, friends. And one more thing, draw a line L, draw a line M perpendicular to the L. So first draw a line L, and next thing is draw a line M which is perpendicular to L, such that. So again draw a line P such that P is perpendicular to. Now again draw a line P such that P is perpendicular to line M. So thus P is perpendicular to L. So this P is perpendicular to L. Thus P is perpendicular to L. You will find P is parallel to L. So this is because you draw P such that angle 1 plus angle 2 equal to 180 degrees. So finally what we can consider is that, friends, so when a transversal cuts two lines such that pairs of interior angles on the same side of the transverse supplementary, the two lines are parallel. So this is nothing but what I have told you in the third point, that it is, friends. So finally our chapter is completed, students. Our chapter is completed. Hope you have understood well. Have a nice day. Keep smiling. Hello students, now in this video we are going to see the summary of the chapter lines and angles, students. So basically in the beginning we have discussed about the water line segments and lines and rays. We know water line segments have two endpoints, lines have no endpoints, and ray have one endpoint. After that, between two line segments we can form an angle, between two lines we can form an angle, between two rays also we can form an angle. Whenever two lines intersect also there will be angles. And in the case of angles, if the angle is less than 90 degrees, they are acute angle. If the angle is greater than 90 degrees, it is obtuse angle. If the angle is equal to 90 degrees, it is a right angle. And we have discussed about complementary angles. If the sum of the measure of two angles is 90 degrees, we say that those angles are the complementary angles, and each angle is the complement to other angle. And supplementary angles, if the sum of the measure of the two angles is 180 degrees, then we say those angles as the supplementary angles, and each angle is supplement to another angle. And next thing is about the adjacent angles. So if the two angles are having the same vertex, if the two angles are having the common side and the two non-common sides are on the either side of the common arm, then we say that those angles are the adjacent angles. And next thing is linear pair. For that it must be adjacent angles and the non-common arms must be opposite to each other. If you satisfy these two conditions, it may be a linear pair. And next thing is about, students, that is vertically opposite angles. Suppose if two lines are intersected and vertical, there will be two vertically opposite angles are there. So, and one more thing is that vertically opposite angles are equal if two lines are intersected, students. Okay. Next thing is about pair of lines. So in that, if you take pair of lines may intersect, and the lines are called intersecting lines, and the common point is the point of intersection or intersecting point, students. So what is a transversal? Transverse is a line that intersect two or more lines at different distinct points. If it intersect at one point, they are not. It is not a transversal. It is like that, students. Transverse is like that. And next thing is angle made by the transversal. So there are different angles, corresponding angles, alternate angles, interior angles, and exterior angles. Whenever the transfer is intersected by two lines, students. And we have discussed the parallel lines. So if you take two parallel lines and there is a transversal which is cutting the two parallel lines at two different points, in this case we will have three results, students. One is each pair of corresponding angles are equal, and we can represent corresponding angles by letter F. You can observe from the two lines. And one more thing is each pair of alternate internal angles are equal. We can understand it by letter Z. And each pair of interior angles on the same side of the transversal supplementary, students. So if these three conditions are satisfied, those are the results of a intersection of a transversal with the parallel lines. And how to check for parallel lines? So if these conditions are satisfied by any two lines, then we can say that two lines are transversal lines. So these two lines are parallel lines, students. So finally our chapter is completed. Our summary is also completed, students. So hope you have understood well. Have a nice day. Don't forget to subscribe Sreenath Academy YouTube channel. Also follow on Instagram and join our Telegram channels. If you have any doubts, please feel free to comment below. Like and share our videos. Have a nice day. Keep smiling. Bye bye, students.